This video will show you how to graph a parabola using the vertex and the intercepts. You should already be familiar with graphing a parabola using the vertex and a t-chart. This is the standard form of a parabola. From this form, you can name the vertex very easily. It is just HK. Here's just a picture of a parabola here. Most parabolas will have two x-intercepts, and what x-intercept refers to is where the graph crosses the x-axis. It crosses in those two places. But it should also have a y-intercept. So there's our two x-intercepts and our y-intercept. If we have the two x-intercepts, a y-intercept, and a vertex, that's going to be enough information for us to fill out our parabola. Here's our function, f of x equals x minus 2 squared minus 9. We know the vertex is going to be 2, negative 9. Remember, inside the parentheses there with x, we change the sign. Outside, we do not. To find the y-intercept, you want to compute f of 0. Remember, f of whatever means to take that 0 and plug it in for x. So in this equation up here, I put 0 in for x, and that's this work showing here. 0 minus 2 is negative 2 squared minus 4. Negative 2 quantity squared is a positive 4. Minus 9 is negative 5. So our y-intercept is the point 0, negative 5. To find the x-intercepts, you're going to solve this equation. Set your function equal to 0, which is what I've done right here. Here's my function, set it equal to 0, and solve. You have two choices for solving this. One would be to FOIL this out and collect like terms and everything. But the easier way is going to be to add 9 to both sides. And then because this is something squared, we're going to undo the squared by doing the opposite, which is square root. Remember something important. When you have solved an equation by taking the square root of both sides, you get plus or minus. So now I have to solve this by adding 2 to both sides. And you don't just stick the 2 here and call it plus or minus 5. Put the 2 in front here. It is 2 plus or minus 3. And then do what I call the high road and the low road. The high road would be 2 plus 3, which is 5. The low road would be 2 minus 3, which is negative 1. These are our x-intercepts. This is enough information to be able to graph the parabola. So the vertex is over 2, down 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. I got to just come down here and estimate a little bit. A y-intercept of 0, negative 5. 1, 2, 3, 4, 5. And my two x-intercepts, x equals 5. So on the x-axis, I put a dot on 1, 2, 3, 4, 5. And I put a dot on negative 1. There's my parabola. I have a hard time graphing with this tool, but you get the idea. There's our curve. Taylor function. First you want to name our vertex. That's the easy thing. Our vertex would just be 1, negative 2. To find the y-intercept, we're going to do f of 0. So plug 0 in for that x. 0 minus 1 is negative 1. Squared is a positive 1. Subtract 2 gives us negative 1. So we have a y-intercept of 0, negative 1. To get our x-intercept, we're going to take our function and set it equal to 0. So we're going to do the same steps. Add 2 to both sides gives us this. Undo the squared by taking the square root of both sides. Because we're solving by square root, we're getting plus or minus. Now this is a little different than the last one. The square root of 2 doesn't simplify out. So when I add 1 to both sides, I get this answer for my x-intercept. That is the exact answer for the x-intercept, but that's going to be awful hard to find on the graph in that form. So you need to do your calculator and do 1 minus radical 2. Square root of 2 on your calculator is 1.414. So do that arithmetic, gives us approximately negative 0.4. Also do the other way, 1 plus radical 2 is 1 plus 1.4, which gives us 2.4. Those are my two x-intercepts. So graph your vertex, 1, negative 2, a y-intercept of 0, negative 1, and then I have to do a little bit of estimating. Negative 0.4 is about negative 1/2, which is about there. 2.4 is almost 2.5, which is right there. And you can see the dots. You can connect those up to be your parabola. I'll do the best I can. And there's my parabola. You might not understand why we do what we do to get these intercepts, but it's fairly simple, and it has to do with the coordinates that are on either the x or the y-axis. When we're finding the y-intercept, That means it's a point on the y-axis. Any point on the y-axis is 0, something. So when you do f of 0, you are letting the x-coordinate be 0, which is what the situation is for the y-intercept. The x-coordinate is 0. On the other hand, when I do this to find the x-intercept, any point that's along the x-axis is of the form x, 0. The y value is 0. Remember, y and f of x are the same. So all I'm doing here is letting the y value be 0 and trying to find the x value. That's why we do what we do to find those two intercepts. Original function, it doesn't quite look like it's in standard form. We would like to have the x squared stuff first, so all I gotta do is flop this around and it becomes this, negative quantity x minus 3 squared plus 1. So name your vertex. Your vertex is 3, 1. Recall that if you have a negative in front of the parentheses, we know our parabola is going to be facing down. That might help us when it comes time to connect the dots. To find the y-intercept, compute f of 0. So put 0 in for x. And do the arithmetic. 0 minus 3 is negative 3. Negative 3 squared is 9, but there was a negative in front in the beginning. Negative 9 plus 1 is negative 8. So this is my y-intercept. To get my x-intercepts, set my function equal to 0 and solve doing the same steps I've been doing. Move the 1 over, gives us negative 1 equals negative quantity x minus 3 squared. Because both of these are negative, I can just change both those signs to have this. Undo this by taking the square root of both sides. And now we have plus or minus 1 equals x minus 3. Add 3 to both sides, gives us 3 plus or minus 1. High road, there's 3 plus 1, which is 4. Low road is 3 minus 1, which is 2. So that's enough information to get my graph over 3 up 1. 0, negative 8 is about right here. An x-intercept of 4 and an x-intercept of 2. Okay, see if I can draw this parabola. This is coming down this way, and this will come down this way, trying to get over here to touch this point over here. I missed it a little, but you got the idea. Last one of this type, it's in standard form, so let's name our vertex. Our vertex is just 3, 2. Let's find our y-intercept by computing f of 0. So put 0 in place of that x and do the arithmetic. 0 minus 3 is negative 3. Square that comes out positive 9. 9 plus 2 is 11. So our y-intercept is 0, 11. Let's do the x-intercept. Let's set our function equal to 0. Solve this by subtracting 2 from both sides. To undo the squared, we would take the square root of both sides, and right there we've got a problem. When you take the square root over here, you're taking the square root of a negative, which gets you an imaginary answer, and you're not going to graph imaginary stuff on this grid. So that says there are no x-intercepts, and that's okay. We'll just have to graph this using some other tools. So let's get started though. We can do a vertex of 3, 2. We have a y-intercept of 0, 11, which is like way up here. It's probably even further off the graph than that. I do know that because this is a positive here, that it's going to be facing up. So I could even kind of halfway fake it, but that's only going to give me this side. I know it's going to turn around. It is symmetric, so I could kind of fake it from here. But to be absolutely certain, I can go back to my old way and use the t-chart. When you use the t-chart, you want to pick numbers that are on the immediate left and immediate right of 3. So immediately to the left of 3 is the whole number 2. And on the other side of 3 is the whole number 4. Do the arithmetic. If you put 4 in here, let's say, 4 minus 3 is 1. 1 squared is 1 plus 2 gives me 3. And since this parabola is symmetric, both of those have to be 3. So over 2 up 3, over 4 up 3, and because that's off the graph and kind of out of the way, I'm not even going to use it. I'm just going to make my curve using those right there. So this was one where the intercepts really didn't help me any. And that can happen. That's why you need to also know the t-chart way.